Next, I'll be working the problems on vertical motion. Now, problem 1 is actually just something that you can get from your notes, so I won't be spending time working on that. You need to look in your notes on the vertical motion page to find the free body diagram and to find the answer to the questions. So moving to number 2. What we know already from the title of this section is that we've got an object accelerating in the air. It's in the air, which means it has to be accelerating. But I'm going to go through my process again. I have a 5-kilogram ball. I have 85 newtons. Okay, without reading anything, I've got 2 pieces of information. Now I read through the problem fully, and I see that it is asking me for upward acceleration. The reason why? Downward acceleration is gravity, but the ball is moving upward, so we want to know how come. Okay, I start then with the drawing. I have a ball. It is 5 kilograms. Remember, kilograms is a mass. It always goes inside the object. It is launched upward. We know it moves upward. And it gives us that force, 85 newtons. Now we need to remember what this is called. We are launching it, we are applying a force, whether that's a throw or a kick, but it is an applied force. It's outside force that we are applying. Now there's one other force at play, and that's the force supplied by the earth. And that force is weight. But we do not have a weight value yet. These 2 forces, though, make up the crux of our problem. Can I find FW? I hope so, because FW, we learned in the last unit, is mass times gravity. Okay, remember also that gravity is 9.8. Mass was given to me, and I put it inside my circle. So I find my weight force by multiplying the mass they gave times 9.8. When I do this, I'm going to get an answer of 49. 49 newtons for my weight. This is vital information because this is my down arrow. Remember also that we said just a moment ago that anytime I have acceleration, I'm really doing an F-net problem. So I have 2 versions of F-net. One version of F-net is mass times acceleration. The other version of F-net is adding my arrows. Or we call this FA plus FW. Now because this all equals out to F-net, I can rewrite my equation to say MA equals FA plus FW. The nice thing about this is that I can solve my problem immediately. If that confuses you though, I want to work it out in 2 pieces. The first piece I want to work out is my arrows. So I'm going to take my applied force and add my weight force. Remember that my weight force is negative. So F-net equals the applied force, 85. This is why labels are very important and they help us out a lot. Plus FW. Now I don't have the negative sign there because remember the negative sign means direction. It is opposite direction to the 85. So when I add these together, and really again I am adding a negative number, I'll even put it into my calculator that way to make the point. I'm going to say 85 and I hit the plus key. 85 plus a negative 49. It's the same thing as subtracting, and I get 36. Now I'm going to take that F-net and plug it in to mass times acceleration. So I rewrite that so that you can see the equation. F net goes right up here. 36 newtons equals MA. Well, I have to look for that M again. It's right here. 5 times acceleration. To get rid of a multiplied number, we divide by that number. I still actually have 36 in there from the last equation I just did. Divide by 5. I get an answer of 7.2. I need to see my decimal place. So acceleration equals 7.2 meters per second squared. Again, you got to remember those units. Okay? If you always do your weight and mass conversions first, then I think these problems are easier than the ones we did up at the top of the page and the very last one on the bottom. I think that they're easier than horizontal acceleration. I'm going to work the next problem. Again, I'll be working it a little bit faster. You should pause if you need to review any of the topics. Got a rocket. That rocket has a weight. I know that it's a weight because it is in newtons. I know that this is describing the rocket because they're found right next to each other. It's an adjective for the word rocket. 1,225 Newton rocket launched into the air with an upward force of 4,250. 4,250. Again, force, newtons, these things all go together. They make them arrows. My question, and that's all that they give me, my question is about the acceleration, just like we had last time. Now, if you remember, there were 3 different equations to use. To get our acceleration, we're going to need to know mass. So again, the first thing I always do with any of these problems is I convert. This time, they gave me the weight force. Remember, newtons means force. I don't know my mass. Gravity is always 9.8. $125. Got to check my unit there. I was solving for mass, so it's kilograms. Okay? I'm going to label it there too, just in case I get lost later. I know where to come back and look. Now I've got my 2 equations I can use. I'm going to do the arrow equation first again. It's because when I look over here, I see 2 arrows. So that's where I'm going to start. And what I know is that what I'm really doing is taking that up arrow and I'm subtracting the down arrow. 4,250. Take away 1,225 and I get a net force of 3025 newtons. Okay? And again, that number is going to get plugged right in to the next F-net equation, MA. So I take this, put it in right there. 3025 equals, and again, I need to know that mass, so it's helpful that I identified it right here. 125 kilograms times A. Again, anytime we multiply, we get rid of that number by dividing. So I've got 3025 divided by 125. I end up with an answer of acceleration is 24.2 meters per second squared. That's the last problem.